Okay, this is Module 1, Lesson 6, How AI Works, Simplified version. Explain AI logic without going into very deep technical depth. We have an image here to try to understand, make a connection to what AI is and demystify it and what it's not, okay, and how it actually works. This is a generative AI made image with Gemini, and I wanted to show the connection between like the Wizard of Oz, who was able to present himself as all powerful, and then when you peered behind the curtain, you saw it was all a charade, okay? And if you've seen like the new Wicked movie, you saw a new visual interpretation of that versus the original film. And so when we look at AI, if we view it as this thing that's all powerful and something that we can't understand, okay, something that we said is not magic, right? It's not it's not really science fiction. It's something we use today and we know how it works. So if we take a peer behind the curtain, if we were to pull it back, it's really just powered by a bunch of data, training, and then the output that it generates being able to give feedback on the output so it gets better, and then repeating that process. And then a side note, I do liken it using this example and using generative AI for this lesson to give us an image. I thought it was pretty cool that it came up with this. I didn't tell it to do that. So just using Emerald, knowing that Wizard of Oz contains the Emerald City, we have this company for this presentation, Emerald AI Consultants. And I was like, oh, that's a little bit of a creativity, something that wasn't included in my prompt that was added into it. But I wanted it to show the AI embodied as kind of like the Wizard of Oz, but more of a, seeing data and it being digital, okay? Peering behind the curtain, data, training, and outputs. And notice, yet again, we have a human at the center, okay, of helping out with this process and creating it and perfecting it, making it better. For our pathway overview, this lesson demystifies how AI works by breaking down the core process into three simple stages: data, training, and output. Using everyday analogies and real world examples, students will understand how AI learns patterns from examples, makes decisions based on that learning, and produces useful results without needing any coding knowledge. By the end, you'll grasp the fundamental logic behind every AI tool you use, from chatbots to image generators. The workforce targets for this lesson: explain the three main stages of how AI works in simple everyday language. Identify real-world examples of data, training, and output in common AI applications. Describe what training actually means and why it matters for AI performance. Compare how humans learn versus how AI systems learn. Predict what kind of output an AI might produce given a specific input and training context. Recognize the role of patterns in AI decision making. Apply this foundational knowledge to evaluate AI tools used in your own life. Key vocabulary for this lesson: artificial intelligence, AI, data, training, pattern or patterns, input, output, algorithm, model, accuracy, and bias. For our live build demonstration, think of a skill you learned, like recognizing your best friend's face or knowing when someone is angry. How many times did you see examples before you became good at it? Okay, we've noted the difference between humans and machines before, of us also not just taking the images and being able to store and have memories of brain. We tie experience into it. So, I mean, you had a good interaction with somebody, that was nice to you, and then that probably helped you recognize them. And then the second time interacting, maybe finding out you have something in common, and then if you wind up being friends, right, you're going to be able to pick them out of a crowd with just a few interactions with each other. Or how about reading facial cues like it says if someone's angry? Well, we learn as a child and we see, our verbal cues and body language from our parents, like when we do something wrong. And so maybe they do furrow their eyebrows together, raise them, and have like a wrinkle in their forehead. If someone gets angry, maybe their face turns red, maybe they're clenching their fist. But we pull in a lot of experience and images to know this, that you have kid books that have animated faces that are showing different expressions. And then we've seen it play out in real life with different people, as well as like television shows and movies, to where we could yet again mention generalizing. We could see somebody and maybe have a good inkling if they're upset or not, and that is because we've seen these images, we've seen these and have experiences in memory, and we're able to make those connections. Have you ever used an AI tool like ChatGPT, Google Translate, or a voice assistant? What did you ask it, and how do you think it knew what to do? So, like Siri or Alexa, it might have been as simple as play me a summer playlist, right? Using Spotify, so it could go directly to your Spotify account. You know, maybe it uses the DJ AI feature that's in Spotify and putting together a curated list for you. And then that output, ultimately, you can, by skipping stuff you don't like, if there's repeats, and giving feedback back to it, you could improve that process to have something that's more tailored to you. So if you showed a young child 100 pictures of dogs and cats and then showed a new picture, how would they know which one it was? What did they learn from those 100 pictures? So maybe it's not the same picture of the same dog or cat, but they saw 100 pictures worth of dogs and cats mixed together. It's a pretty good chance they're going to be able to generalize seeing a picture now of a different breed of dog, or just a different dog of the same breed and cat. And they looked at features like fur, right? What the tails look like, what ears look like, and be able to tell the difference between like the dog and the cat and something like a mouse. So, what do you think would happen though if you trained an AI with only pictures of golden retrievers? So, in its training for dogs, that's the only thing that gets put into it are pictures of golden retrievers. So, would it be able to recognize different breeds, especially ones of different size and shape, such as a Chihuahua? Would it recognize it as a dog? I got it to generate this image to help us have visual context here of what if the training data input was just a bunch of pictures labeled dog, but notice they're pictures of a golden retriever. Okay, so it has high recognition of golden retrievers being a dog. Okay, that's all that its training is showing. So this is introducing bias in the form of, we have a breed bias here. We don't acknowledge other breeds of dogs. Okay. And this is going to cause issues because then it's going to make its prediction of what it thinks it sees. So we put in this input image of a Chihuahua that's not in the training data. And maybe it starts making connections to other animals that it's seen. And you might have a scenario like this play out, that this is 98.7% confident that this might be a rat. Okay, due to the bias in the training data. Low confidence in it being a dog, so we're way off on what it should be labeled a dog, right? It should be flipped. That was all because of the data that was given was just golden retrievers. So this led to a bad outcome. How AI works. Today we're answering one big question: how does AI actually work? We'll skip all the complexities, the math, the coding, and we'll learn the three-step process that powers every AI tool that you've ever used or will use. By the end of this lesson, you'll understand the logic behind, say, ChatGPT, image generators, recommendation systems, and more. So the three stages of AI, okay, they all follow the same basic process. First comes the data, okay, it being trained, having many examples that are labeled. Second comes the training. AI learns patterns from all the previous examples. And then the output, the AI makes a decision, or maybe it makes a prediction or an answer based on what it learned. So think of learning to cook, how you learn to cook, if you do, or how others learn. You would see recipes that you might have cookbooks in the family or have bought one or online recipes. And all those are your examples of what, let's say, like Southern food, okay? And you start building that repertoire of having those recipes, and that's your data, the type of ingredients you need, the steps that you take to make those dishes. Well, then the training phase for you was actually making like recipe one, okay? First time, maybe it came out too salty. Then you adjusted. Maybe it needed a little acid to perfect it. Maybe you have to then, after you've perfected the recipe, go back and somebody needs a modification due to like a food allergy. And so you can train over and over again with these dishes to the point that your output is you could replicate that dish, or you could go to the point that you can make a new meal without following that recipe. So just based on what you know now, you could have subtle variations. So an image to help solidify this, anchor this in our minds of this input phase of data, training, and output. What if we had the chef here? Okay. And in the data input phase, in this case, he's studying all of these French culinary techniques and recipes. So we have French classics, okay, looking at like technique, flavors, balance, and tradition. Okay, so this chef Andre that was created by AI is not a real person. He's studying the types of sauces in French cuisine. Okay, he's studying certain recipes, beef bourguignon and creme brulee, ratatouille. Then the training phase goes to him following these recipes one at a time. He's practicing, experimenting, and noticing, okay, maybe attempt one was too salty. Attempt two was too thick of a sauce, okay? To the point that you get it better. And then when do you decide that it is perfect of what you were looking for? And so that process could be iterated, it could be repeated again and again to ultimately to create not just that recipe of like ratatouille following it or a creme brulee, but you might want to make a raspberry creme brulee. You might make a coffee infused one. Well, in this case, is showing that our output being something completely unique is the idea of like Cajun food using French techniques in it. If you've been to New Orleans before and seeing, okay, these things that we would have with seafood, okay, and the different sauces that would be used in the French cuisine. But now we have these Cajun spices and seasoning. So maybe this is a Cajun cream sauce, and we have this écrevisse scallop dish that didn't exist before, but it's all coming from Chef Andre's initial data that he was taking in and training and getting to the point where he could create these new dishes. One AI imperfection, there are some in here to have fun looking for them. It is this Cajun seasoning can. We laughed whenever we first looked at it and that it didn't have like Tony Chachere's or something like that. And this is actually like just a large can that says Cajun seasoning. And I've never seen seasoning be in a can like that, like a metal, like a bean can. Okay. We do notice Tabasco sauce, a brand that we could recognize there, even though the label is not clear. Okay. So stage one, data, showing examples. Data is just information or examples. If you want to teach an AI to recognize dogs, you've probably showed it thousands of pictures of dogs and non-dogs. If you want to write emails, you've shown it examples of good emails what to look for. You've shown it examples of what are labeled not good emails. But it doesn't see or read these examples the way that we do. Okay, it's breaking them down into patterns, looking for colors that are in there, shapes, word choices. Those would be some patterns, grammar patterns. So maybe it's analyzing the use of emojis in there, the certain words, and then is it grammatically correct? The more examples you give, the more patterns that the AI can spot. Then in the training phase, the AI had studied all the previous examples and found out what makes a dog look like a dog or what makes an email a professional one versus not professional. The AI system makes guesses with new images given to it and is able to make those predictions and test in its training if it got it right or wrong, and then it adjusts. And this happens millions of times very fast, so it could get better at having its predictions being more accurate to where it could tell you with high certainty that this picture of what it believes is a dog, that it is a dog. It's similar to how you learn something like your times table. You had to practice that table over and over again to where you weren't really having to, on paper, write it out. You didn't have to think about it much, that you knew certain combinations had certain results. The AI is learning, it's just in a different way. Now, when the training is done, so all the data that it has and all of the predictions have gotten to where they are making good predictions that the outcomes are what are expected, that it's been able to be trained on new and novel scenarios, data coming in that it wasn't trained on to see can it still make accurate predictions. That's when you say the AI has a model, okay, and that model is a version that can now make new predictions. Then the output stage. Once an AI is trained, it's ready to work. You give it new information and it produces an answer or decision. So you show a trained AI a new picture of a dog and it recognizes it as a dog because it learned dog patterns. Asks ChatGPT to write a poem and it produces a poem based on patterns it learned from human written text. The output note is not copied from the training data and it's not copied and pasted from anywhere online. It's actually a new synthesized creation based on learned patterns. This is why AI can do things it wasn't specifically programmed to do. Now, how humans and AI learn differently, you learn from, like we said, with the child example of faces and emotions or recognizing a friend. We could learn from just a few examples and have real understanding. If someone shows you three dogs and tells you what a dog is, you probably have a high chance of recognizing, in general, other dogs. But AI is going to need thousands or even millions of examples to learn the same concept. The key difference is we could transfer knowledge quite easily. Okay, so one situation we saw this was a dog, and another situation we're able to make that connection from before. AI doesn't transfer knowledge as easily. Now remember, it doesn't have that experience and emotions tied in to it like we have that helps us have those mental anchors. But we could learn from one person explaining something. So maybe just that one interaction with somebody learning something. Another example would be like the first time you touched something that was hot, okay, got near an open flame, or touched a hot pan, okay, or accidentally touched the grates in the oven while pulling something out. You probably learned from just that one example of in generalized other stoves, other hot objects that are like that. Are there signs of it turning red? Is it giving off smoke? Is there a light on indicating that the unit's on and it's probably hot? And we probably want to do everything possible to not do the same thing we did before because we've transferred that knowledge of even that one time, and that's ultimately impacting how we interact with things that could be dangerous. AI needs data and it needs a lot of it and it needs it to be structured and organized. Now, everything AI does comes down to patterns, noting these patterns that it finds in its data. So a face recognition system is going to learn patterns like a face normally has two eyes, a nose, and a mouth arranged in a certain way. That in general equals a face. Well, it's going to have to, that would be a bias against if somebody had lost an eye, okay? And were they wearing an eye patch? What if somebody has a glass eye, okay? Would it recognize somebody that had been burned? Okay, what about different skin tones? So those are all the things that would need to be included in the data so that it would be able to recognize people and to do it fairly. A spam filter learns patterns like emails with words such as free and click are often spam. A recommendation system learns patterns like people who watch this movie often watched that one. If the pattern doesn't exist in the data, the AI cannot learn it. If the pattern is weak or confusing, that's when the AI might make mistakes. Understanding what patterns exist in your data is half the battle. So, a real world example with a streaming service and its recommendations, such as Netflix, it was trained, they trained their AI on millions of user choices. The data was what movies you watched, the ratings if you did rate the film after. Did you complete the film or TV show? Did you skip parts of it? Did you completely quit halfway through a show? Then it's able to pick up patterns like this person in this account, this person maybe who watches comedies, and the same person that watches action movies, it might find the pattern that they often like thrillers. So then it could suggest to somebody that had watched a comedy and an action movie, it might suggest a thriller to them. Output, it recommends a new movie that you haven't seen. Now, note the programmers, software developers for Netflix did not put in data specifically for, say, Matt. They didn't know what I wanted to watch or what I might like. The AI learned patterns from your behavior or my behavior and millions of other people on their website to be able to get better at the recommendations. More data means the AI sees clearer patterns. Now, why training quality matters? Not all data is good data. We mentioned before garbage in, garbage out, or garbage data in, garbage data out. We had the image of the blurry car the AI might recognize as a trash receptacle. If you train an AI to recognize faces using only pictures of one group, such as their skin tone is different, it will perform poorly on other groups. This would be an example of bias. If your data has errors or is too limited, your AI will learn bad patterns. If your data is huge but messy, training takes forever. The quality of your training data directly affects how well your AI works in the real world. This is why companies invest heavily in collecting and cleaning data before training begins. So one example of bias here with the real world example, if we had a camera that was AI enabled, that had computer vision, and it was to recognize humans. Okay, so maybe for it to open a door automatically and it's opening it for humans, we're not wanting it to open for a deer that walks up or a squirrel. Okay, so just in general, humans. Well, even if it was shown different skin tones to show different races, ethnicities, backgrounds, okay, even if it was shown how we could vary in somebody might be in a wheelchair, what if somebody had lost a limb? Even if it was good at having a lot of data on what humans look like to identify humans, we could have bias from something such as occlusion or something block, which is just something that is blocking part of our vision. Just like if we were looking for something and part of it's obscured behind a tree or something, then we might not recognize it. Okay. So occlusion is the problem when what you're trying to look at and identify, or in this case, the AI is trying to look at, is blocked and by something it doesn't recognize, which could completely throw off the prediction. So in this first example, we'd have high success rate that this is identified as a person, 99.6%. The same person holding an umbrella, note it's not viewing it as an umbrella and a human. We have this occlusion where the human's partially covered, and it's making it not have a good confidence of detecting what it is. 41.3% human, quite low confidence. Okay, now even if it knows what an umbrella is and had that in its data, okay, it has a high probability that that is an umbrella. But because of the bias of it not being trained on data for humans holding and interacting with objects, we ultimately have a misclassification and we have it not recognized as a human. Everything else besides the umbrella is an unknown object. So it would miss the person in this case not open the door for them when they were supposed to be allowed to enter. Note, if an AI system is mostly trained on one type of face, lighting condition, pose, or appearance, it may learn that version as the default. When it sees someone outside the pattern, such as a darker skinned man or woman, a person wearing religious head covering, someone in poor lighting, or someone partially covered by an umbrella, like the previous example, then the system may become less accurate or fail completely. So this link here, we have a strong real world example that was done that looked at a facial analysis system, okay, and found that systems worked much better across major companies, that these systems worked better on lighter skinned, in particular men, than on darker skinned, in particular women. The study reported error rates as high as 34.7% for darker skinned women, while the maximum error rate for lighter skinned men was only 0.8%. The major reason for this was the training data, okay, was heavily it was comprised of a lot of lighter skinned subjects, okay? So that introduced bias into the system. It might not have been inherently, and the person behind all the people that were providing the data might not necessarily have been thinking, oh, I want to exclude a certain group, okay? That they might have had a lot of examples of people in jobs before. They might have had images themselves. And if they didn't recognize these patterns that the AI was, maybe they thought that a group was represented when they weren't, okay? Or maybe it was because it was historical. Maybe one company had been around in the tech sector. Tech companies were heavily men in the past, okay? And a lot of white men, so hence the lighter skinned men. So if you went through pulling data from a lot of major companies throughout history, then yeah, that's going to infuse this bias in the system where it might not recognize somebody that looks different. And that would lead to bad outcomes, such as maybe not recognize the person as a person for a facial analysis system to let them in to have access to something, to be able to do the duties of their job. Putting it all together. So data, it feeds the AI examples. Training lets it learn patterns. And output is the result when you use it. This cycle happens for chatbots, image generators, voice assistants, recommendation systems, and medical diagnosis tools. Understanding this simple three-step process of data, training, and output helps you to think critically about AI. You can now ask yourself, what data was this trained on? Is the data good and fair? Can I trust the output? And these questions will help you use AI responsibly in your career and in your life. So for our guided build, we're going to see how AI might be trained on recognizing professional emails versus more casual ones. Okay, so we'll look at 5 examples of professional emails. Okay, and note what usually constitutes a professional email. Then look at 5 that are more casual So then when you would be presented a novel email that you haven't seen before to analyze, you would use that data, the examples that you had, to make a determination of, do you consider something more professional than compared to casual? Okay. This is how similar to what the AI would be doing. Okay. For you to get to the point that you could make an assumption or a decision on an email. So I used ChatGPT and actually used generative AI capabilities or text generation with ChatGPT. My prompt was, I need 5 examples of professional emails and 5 examples of super casual, non-professional emails, and separate these examples. I figured that it would be able to separate them so we could visually see them separated and not have them mixed together. So our examples of professional emails, what if there was a need to reschedule a meeting? The subject says request to reschedule meeting. Dear Mr. Johnson, we have a greeting. I hope you are doing well. I am writing to ask if we could reschedule our meeting originally planned for Tuesday at 2 p.m. Would Thursday at 10 a.m. work for your schedule? I apologize for any inconvenience and appreciate your flexibility. Best regards, Matthew Harris. What about a job application follow-up? Follow-up regarding application. Okay, maybe they put dear hiring manager, they might not know a name to put. I hope this message finds you well. Okay, I recently applied for said position and you're wanting to follow up on the status of your application. A request for additional information. Dear Mrs. Carter, I hope you're having a great day. I'm reaching out to request more information about the upcoming training session scheduled for next week. Thanking somebody after an interview. Dear Mrs. Williams, thank you for taking the time to speak with me today about the position. I appreciated learning more about the role, the team, and the goals of the organization. They reiterate that they believe they're a strong candidate for the position and thank them for their time and consideration. Then we have an apology for a delayed submission, maybe a student assignment. Dear Dr. Smith, I apologize for the delay in submitting the requested document. I understand the importance of meeting deadlines and regret any inconvenience this may have caused. I have attached the completed document for your review. Moving forward, I will make sure to communicate earlier if I anticipate any delays. Thank you for your understanding. Now we would connect these to, we would have examples, okay, just as we saw examples and learn what is more professional than versus casual. What if we gave examples like the professional ones to AI, and then we gave it examples of these casual ones that are more non-professional? Subject, need to move the meeting. Hey, very informal greeting there. I can't do Tuesday at 2 anymore. Can we just move it to Thursday at 10? Let me know. Thanks, Matt. Okay, we went very casual with our greeting here. Our subject is not clear on there's a need to move a meeting. What meeting is it? Okay. The contraction, usually you write out words in a professional email. I cannot do Tuesday at 2 anymore, rather than saying PM. Needing to show that you acknowledge that it could be inconvenient and including an apology in asking the person to move a meeting. Okay. Let me know seems very informal. Thanks. Okay. When you're getting somebody to go above and beyond here and moving the meeting when it could be inconvenient to them, they might want something a little more than that. Now, what about checking on my job thing? Super vague for a job application follow up. This subject is probably going to lead the person not to click on it at all because they're not going to think that's a good candidate for the job. Yet again, hey, I applied for that job, not specific. Y'all, just checking, Matt. Question, hey, question, what type of question? What's going on with that training next week? Do we need to bring anything or look at anything before then? Thank you email after an interview. Subject, thanks. They have no idea what the thanks is. Okay. Hey, thanks for talking with me today. The job sounds pretty cool, and I think I'd be good at it. Hope to hear something soon. Matt. Apology for missing a deadline. Late thing. Hey, sorry I didn't get that thing turned in on time. I've attached it now. So note that AI generating these examples, it's already using the patterns for us to show how we need these examples in the first place to train an AI. The patterns that it would then start to recognize would be the clear subject, that the greeting for the professional one is probably going to be dear, okay, or good morning, good evening with the person's official title based on the context, that we're going to have a formal greeting, okay, that it might be, and it might be hello, but more informal is going to be hey and hi. That it's going to be clear language and professional. It's probably not going to contain contractions like didn't, okay, and it's going to sound more as if you were talking to the person there like you did at the interview, okay, not dropping the standards because they're not physically in front of you at that time. My bad, like that example there. Now create an example of an email that students or technologists can analyze. So you're taking on the role of, based on the 5 examples that you saw a professional and then 5 on the casual side, this one's not labeled. So what if we had question about Friday's assignment? For the teacher, that would be quite clear of a subject. Hey, Mrs. Parker. Okay. Hey's more on the casual side, but maybe this is a college professor. Maybe this person knows that that would be their preference. Okay. And even if they're a doctor, okay, level, you might have a professor that's Dr. Parker. That person, she might have told them that they're able to call her miss, that maybe they don't prefer to be called doctor. I wanted to ask about the assignment that is due on Friday. Connects back to our subject. I looked over the instructions, but I'm still not totally sure what we are supposed to include in the final paragraph. Could you explain that part again when you get a chance so it's convenient at their time? I don't want to mess it up or leave anything important out. So thinking back to things that we saw in the professional versus the more casual one, we might see that this is somewhere in between, that is leaning more to the professional side for a student emailing their teacher, with a little bit of the informal on how they how they get the person's attention, and then also how they talk about not messing something up, okay, and then not putting the full name, and thanks is more on the might be seen as informal in this scenario rather than more formal. Thank you for your time. So note AI, what we did, analyzed it and said that it is mostly professional, the example that it generated, but slightly casual. It would probably be acceptable for a student emailing a teacher. Okay. The message is respectful, clear, and focused on schoolwork. However, it is not fully formal because it uses a few casual phrases. It looks at our subject line. We looked at the greeting and the difference between hey versus hello and dear. Does it have a clear purpose? Okay. What is the closing like? So it's a little more on the casual side with the hey, I don't want to mess it up, and when you get a chance. Now, note that these aren't intended to be rude, they're just more conversational. Okay. So a more professional version, if it was needed, might be more of I want to make sure I understand the assignment correctly and include all required information. So that would be kind of us looking at the examples of the good ones and for professional setting and the ones that are more for informal and casual situations. And then we were able to then look at examples of our own other emails and our own and be able to see, do they fit the context needed? This would be done with millions of examples for the AI to be able to make these connections, to notice things like this, to see, is it giving output of an email that is appropriate for the situation. So that is what was for the guided build section. Now, what if every email in our training data was from one industry or one culture? Would the AI's understanding of professional be fair? Why or why not? This introduces bias and data quality concepts naturally. Okay, so the bias that might be put in, what if this was only for college and professors and maybe it had a lot of them labeled doctor? And so it's always identifying people as doctor even when they're not. Okay, so it might lead to incorrect assumptions of somebody's title. Okay, what if there are more cultures that interact with each other more formally that you have in situations rather than informally? Okay, such as in Spanish culture, when do you address somebody, more informally with two? Okay, how do you get somebody's attention in a formal way versus informal, whether in person or not in person? And this is the type of data that would be needed so that way you're not potentially offending somebody in the way that you interact with them. You'll complete your lab. You will choose one AI tool that you use regularly, such as a recommendation system like YouTube, Spotify, TikTok, Netflix, Amazon. What about a chatbot? Maybe you use a voice assistant like Siri or Alexa, and write down the name of that tool. Think about its data storage. What examples did it need to train on? You have an example if it were YouTube recommendations. You have a task of a writing. Think about its training stage, think about the output stage, and consider quality and bias. For example, if a music recommendation AI trained mostly on English language songs, would it recommend music in other languages? And then write your final reflection. If you were the person designing this AI, whichever one you chose, what data would you want to include to make it better or fairer? All the work submitted will be part of your portfolio artifact. Here are common problems that you might face doing this assignment with solutions given. Be sure to read over the best practices for this lesson and to answer the questions for your reflection journal. And that concludes this lesson. Thank you for your time.